Now, there are two ways to work out the value of r and the value of alpha. There's a really easy trick, or there's a proof. I would very happily show you the proof, but I would rather show you the trick and perhaps do a little video where I show you the proof and you can choose to watch it or not. The proof is one of those things that's quite interesting, but actually you don't need it, you can always just use the trick. There are some proofs that we haven't done for the identities. I'm really hoping that when February comes along and they limit what they're going to test us on, I'm thinking, well, how can they limit things? Because different people going on to do different subjects will need pretty much the whole syllabus. I'm wondering if proof is one of the areas where they might chop things out, so that's why I perhaps haven't done all the proofs at this point. Fingers crossed. If they don't say that, then we'll have to do it. But anyway, so yeah, there is a proof for how this trick works. I vote we use the trick today. I'll show you the proof on a little video at some point, and you can watch it if you want. You don't need it, but you can watch it if you want. I only say that because I did the proof for the other group, and I wish I hadn't. So I'm sort of, I'm a little bit older and wiser. Here's the trick. And the good news is that with these questions, because this could either be written as a sine curve shifted that way or a cos curve shifted that way, we made that point yesterday. Here's the trick. The trick works if they're asking you to write it as a sine, and they always tell you what they want you to write it as. They ask you to write it as a sine. Just need to make sure that of the two terms, the sine term comes first. I call that lining it up. So they want me to write this as a sine, and the sine term is first. Right. So here's how the trick works. If you want to know why this trick works, then you'll have to watch my little video, or it's in the textbook actually. Go straight in the textbook. I'll give you the page reference if you're desperate. What you do is you picture a little right-angled triangle where that's r and that's alpha. The coefficient that comes first, which in this case is sine, because I want it to be sine, goes as the adjacent side. Now that's potentially confusing because we're perhaps used to sine involving opposite and hypotenuse, and then the second coefficient goes there. Okay. I use Pythagoras to work out the length of r, and shift tan to work out the length, the size of alpha. You can prove that this angle here will never be bigger than 90 degrees. It's always a shift of between 0 and 90 degrees. So I don't need to worry about any other solutions. So go on, just work out those two values for me. The hypotenuse will be the size of r.
What are we working out, Red?
So you're working out r using Pythagoras, and you're going to use shift tan to work out alpha, because you know the opposite and the adjacent, so that's just GCSE soccer.
This is the adjacent. Don't overcomplicate it.
You've been told, Lily. I'm a little bit scared. Right, so James, have you got the value of r in surd form? James Powell?
I'm just giving the 5.83.
Yeah, well, so it's 25 and 9, so we're happy that could be root 34. I'm going to leave it as root 34. So it equals root 34, but you're quite right, that's 5 and a bit. It's not working. And Isabel, you've got the size of alpha?
Oh, no, don't ask me any questions, please. I'm still writing today.
Okay, so we know that tan alpha is opposite over hypotenuse, is 3 over 5, so alpha's going to be shift tan of 3/5. So George, have you got shift tan of 3/5 for me?
Yeah.
Which is?
30.96375653.
So 30.96, I'm going to round to 31.0, although I'm probably going to store that on my calculator in case I need an accurate version of it.
I'm guessing.
So what we're saying is that this combination of a sine and a cos gives us a sine curve that's been shifted 31 degrees backwards and has been stretched by 5 and a bit. Let's check. I'm going to sketch it. Here's one I prepared earlier. So, has it been stretched to 5 and a bit? Yes, it has. Look, it goes up to almost 6 and down to almost -6. Has it been shifted backwards 31 degrees? Well, normally the sine curve starts here, but yeah, look, it's been shifted backwards 31 degrees. So we've very quickly and easily, using my trick, been able to say what that combination of sine and cos give us. Okay? Now, let's say they wanted us to write it as a cos curve. If they wanted you to do that, they will always tell you. So let's say we want to do the same thing, but this time we want to write it as cos theta. Am I using theta? Yeah, x. Sorry, x. This time, if it's a cos curve, it's a shift forward, so it'll be. So let's use the same question, but we've got to line it up. So I'm going to have 3 cos x plus 5 sine x. They want me to write it in terms of cos. They will always give you this, so you don't have to worry about whether it's a plus or a minus alpha. They will always tell you. My trick will always work. So it's lined up, same right angle triangle, r, alpha. The first coefficient goes there, the second coefficient goes there. Do we get the same answer? That's the question. Have a go. You can use the cosine rule. It is a little bit overcomplicated, yes. So you should find that r is the same. Obviously it's the same 2 dimensions, just flipped around. But the shift is different. Although, surprise, surprise, it's the complement to 90. So I've got tan alpha is 5 over 3. So alpha is shift tan of 5 over 3. I'll put the calculator in. God, she's got 2. Got that quite. Shift tan of 5 over 3. Oh, this is in shift setup. Thank you. 59.0, which is as expected. And let's just double check. Let's just go back to Desmos and just say, same curve. Same curve. Is it a cos curve that's being shifted forwards 59 degrees? Well, cos normally starts here, and yeah, it's been shifted forward 59 degrees. So there are four eventualities that you get in this sort of question. So if it's a sine plus a cos, you could be asked to write it in terms of sine. So it might say, write this, where a and b are different values, as r sine x, and if it's this, it's a shift backwards, which is plus alpha. We replace x with x plus alpha. If they want you to write it as a cos, you just need to make sure that you've lined it up with the cos term first, and they will nearly always have done that. What are the other two eventualities? Well, if I go back to my original function here and change it from not one function plus the other, but one function minus the other, it's still a sine curve. And if I want to think of it in terms of sine, remember sine starts here, this time it's been shifted forward. So if it was a sine x minus b cos x, and they wanted you to write it as a sine, it will be a sine that's been shifted forward. Remember, replacing x with x minus alpha, it's the opposite to what you'd expect, that's a shift forwards. And then the other eventuality, which I'm not going to show you, but sometimes crops up, is if they want you to write that as a single function, and that can be written as a cos curve, which is now, I'm never going to remember all four of those. You don't have to. Every question we're going to look at will always tell you which form they want it written, so you'll know whether it's a plus or a minus. The only thing you need to make sure is that this is the first term in your expression. So here we go, first example. They want us to do one of these, but they've told us how they want it written. So I haven't got to worry about remembering whether this is a plus or a minus. Have they lined it up? Yes, they have. Sine and sine. Yes, Pat?
Should we write those in our books?
I think it's probably worth having them down there, but you'll always be shown which one it is. So we are being shown in this question that it's that one.
Cool.
So use the trick. Use the trick. A is 1 and B is the square root of 3. Don't worry about the minus sign. So when you use the trick with this one, you're not going to involve the minus sign. You're just going to say, right, that's alpha, that's r, that's 1, that's root 3. Not worry about the minus sign. That's dealt with by the fact that you end up with that minus that angle. So use the trick. And then this question wants you to have a sketch. So see if you can sketch it. I note that this one they want the angle in radians. It's a pain, but it's actually not too bad because of the values involved.
Right.
So you should punch the air in these questions, because whatever part B is, and there are some quite fiddly part Bs that we need to deal with, part A is just easy because of the trig. So I've worked out my R and my alpha. It's always between 0 and 90 or 0 and pi over 2. So I'm going to worry about other solutions. I'm going to worry about finding other solutions. It's just always that. I note that that's 60 degrees. So we're asked to sketch it. Well, I'm always going to start with a normal sine curve. Multiplying it by 2 means that rather than going from 1 to -1, it's going to go from 2 to -2. And you regularly get questions saying, what's the maximum value? X has been replaced with x minus pi over 3, which I am so much better with degrees, so that's x minus 60. I know that when you replace x in any function with x minus something, it shifts the function forward. It's the opposite to what I expect. So I need to shift this function forward 60 degrees. Now at the moment, that's 0 and that's 90. So 60 degrees will be about here. So the curve is going to look like that. So that's my original sine curve. That's the kind of curve that shifted forward, and I really ought to continue it. Sorry. So it doesn't start arching up there, it's going to. Does that make sense?
Yeah.
Why is it 2 minus 2 something?
Because if you take a normal sine curve, which goes from 1 to -1, and multiply it by 2, the whole function multiplied by 2 is a stretch, isn't it? So that's why it goes from 2 to -2 instead. Okay, second one. They want me to write this one as a cos, but they've given me the fact that it's going to be minus alpha, and it's already lined up. Happy days. Use your trick. This one turns into a solve problem, but use the trick for part A, guaranteed 2 or 3 marks. probably best to leave R in surd form.
I know.
Back in degrees now.
So is it always determined?
Yes, yeah, because in my little trick, the coefficients become the opposite and the adjacent.
Right, yeah.
You'll see why if you watch my proof, which I'm sure you will do, George.
What's that?
You'll see why if you watch my proof, when I haven't done it yet, but I will do
Oh, I will. Maybe the help I can get.
it. You don't need, no, don't look at the proof then. That's not something you need to do, all right? You can always use the trick.
You don't trust me, do you?
Always use it.
I'm so confused when you don't want to show the proof, because it's really complicated.
Yeah, it's just really it's just really fiddly. And well, unnecessary? It's just, you know.
Okay.
It's on, I mean, it's on page 182 of the textbook. Please feel free, if you want to go through that method every time instead of using my little right angle triangle trick, then feel free. Don't let me stop you. So can we see how this one is going to play out? We are hence asked to solve this equation, but I've just shown that this is the same as this. So I can rewrite it like that. And now I'm going to divide both sides by square root of 29.
So,
Yes. Have I got it wrong?
I'm not going to say that. Does it sit at the bottom?
No. It's, if they're lined up, the first coefficient goes on the bottom, second coefficient goes on the side. That's part of the trick. If they're not lined up, write them lined up. And by lined up, I mean if they want you to write it as a cos, make sure you've got the cos written first. I've only ever once seen it not lined up. Now, the previous question asked us to sketch this curve. I need you to be clear that when I'm solving this equation, I'm actually going to do what we normally do when we've got something other than just x or theta there. I'm going to do it for the normal cos curve. So I'm basically sort of substituting that with something, and then I'm going to add 68.2 to all my answers. So because I'm not dealing with theta, I'm dealing with theta minus 68.2, I'm going to change my units. Oh dear, what's that? So that's 291.8, is it? So I need to make sure I'm going a little bit backwards and don't go all the way that way. So that's just like we do when we're solving cos 3 theta. We change our range of values. This is not 3 theta, it's theta minus 68.2. But I've drawn a normal cos curve to solve it. So 3 over root 29 is root 29 is sort of 5 and a bit. So this is about half, isn't it? So I potentially have got, I don't know, might be an answer there, might be an answer there, I don't know. So I'm going to do shift cos of that and see what my calculator gives me. That's going to give me my solutions for this. And I'm just going to add 68 to them to get my solutions for that. And I don't know, my diagram is a bit sketchy, so I don't know whether I'm going to get a solution there, that's the bottom, or whether I'm going to get a solution here before that.
How do you just draw right off the top of your head?
Well, that's the cos curve,
Yeah.
which I just know.
Yeah, no, I know that as well, but...
Yeah, so that's just, we just
You
use
can
that.
do that as well, but like.
Oh wait, it's just a standard code?
Just the standard cos curve.
Oh,
Yeah,
I thought
so
you like pushed it back somewhere.
right, no, so that's an important thing. To solve this equation, I'm not sketching the shifted curve. I'm sketching the normal curve. So what we've got here is this axis is not the theta axis, it's the theta minus 68.2 axis. It's a bit fiddly, but it just makes it so much easier to solve.
That makes it 10 times more.
Now, because I get 56.1 as my first solution, I know there's another solution here. Sine is symmetrical, so that's going to be at minus 56.1, which is in my range of values. And then the next solution will be 360 minus 56.1, which isn't in this range of values. So that one I haven't got to worry about. It's just those two there. So my solutions are, that's what theta minus 68.2 is. I've just got to add 68.2 to both of those. Now I told you part B's are fiddly, but don't forget we've got ourselves 2 or 3, maybe even 4 marks for part A. So we should get 12.1, which is that one, plus 68.2, and 124.3, which is that one, plus 68.2. I note that they're not using their memories to store these angles. I would have stored that in my memory and that in my memory and then used the memory versions, but I'm being over cautious, unnecessarily cautious. So there tend to be two sorts of part B. There tend to be ones that are to do with graphs, and there tend to be ones that are to do with solving. So let me give you one to try before I see you on Tuesday. Page 184, question 5. We'll have a quick look at it first now. Page 184, question 5. Yeah. So, 184, question 5. Part A, I'm hoping you can all do without breaking sweat. They tell you how they want it written, and it's already lined up. Use the trig. They then want you to say, right, when does the graph of that meet the y-axis? Well, that is the same as that. And I know, because it's stuck on a post-it next to the toilet, that if I want to know where a graph crosses the y-axis, I make x equal to 0, or in this case, theta equal to 0. The maximum and minimum values of that, well, I've changed that to that, and I know what the maximum and minimum values of that. Well, I don't yet, but you will know. And then part D is tricky. I'm interested to see how far you can get through that. I'm hoping that everyone is going to get, part A. That's the trick. I'm hoping you'll then have a punt at B. C you should be able to get, because it's obvious. D is trickier, but some of you I know will have a go. Page 184, question 5. So that's for Tuesday. Your homework is for next Friday, and you've got plenty of practice in between.